Welcome back, my audience. Welcome back to my math channel online today. In this video today, I would like to share with you about the topics of the rational zero theorem. In the past, we have learned about the factor theorem, the remainder theorem. Now we progress to the last one, which is the rational zero theorem. In the course of pre-calculus math 12, in the unit of polynomial function. So what is the rational theorem? Let's look at the example on the board. We will consider this expression 3x squared plus 2x minus 8. So I have a table on the board here. One, I am talking about possible factors, and the second column is corresponding zeros. Now, let's talk about the factor first. So let's get the idea, concept of what factor means first. So let's say if I have a number 24 and I factor this number, this will become 6 times 4, or I can have another choice, 12 times 2. All of this number we call a factor. That is for one number we learn in elementary. Now in high school, we have a long expression, and it could be a quadratic function like this one, or could be a degree of x to the power 6, x to the power 7, we learned yesterday. So any of this number here is a factor, and we can put them in the bracket, in two brackets, in such a way that these brackets time together, they get back to the original number. And the same like factor in high school, we break the expression into two brackets, something like this. But make sure that these two brackets time together, we get back to the original expression. So let's examine the possible factors of this expression. Now pretend that I don't know the midterm of this number. So that's why I put a dotted here and missing this. And I just look at the first term here and the last term here. Then I can inspect the possible factor for this expression. Could be two brackets timed together, like the way we factor like this, will be 3x plus 1 times with x. And actually, I should put an and subtract, right? Because it could be negative, positive, and subtract x times 8, and subtract 8. The next bracket could be 3x plus and subtract 2 times with x plus and subtract 4. The next one could be 3x plus and subtract 4 times with x plus and subtract 2. Next one, I could have 3x plus and subtract 8 times with x plus and subtract 1. So these are the possible factors of this expression. And why? Because the reason, if you multiply 3x times x is 3x squared, you get back to the first term. The last term, let's check the last term, because we don't know in the middle, right? I assume that I delete the middle. So these are just the possible. That's why I said possible factors, right? Not real, it's not actual, but it's possible. So if you multiply the first term with the first term, 3x times x is 3x squared. The last one times a is you get back to 8. 3x times x is 3x squared. 2 times 4, you get back to 8. 3x times x is 3x squared. 4 times 2, you get back to 8. 3x times 3x plus and subtract 8 3x times x is 3x squared, 8 times 1 is 8. And therefore, I'll be able to inspect these are the possible factor. Assume that I don't know the midterm, right? That's the possible factor. So if I set up each bracket here equals 0, because I'm talking about corresponding zeros. So let's say, what is a 0 mean? 0 mean the function cross the axis. So we call that as the x-intercept of the function, or could be the roots of the function. So the function can have a roots, can have one root or two roots or many roots if they are across the x-intercept, the x-axis. And that is the 0. And therefore, to solve for the value of 0, which is the y value equals 0, right? And to find out what is the x value to make the y equal 0, we solve for the x value, and we call that value is the 0. So let's say if you set 3x plus 1 equals 0 and you solve for x, the corresponding 0 for this one will be, let's do it down here, 3x plus 1 equals 0. Move it over, 3x equal minus 1, x equal minus 1 over 3, right? So the corresponding 0 for x will be plus or subtract 1 over 3. If you set the second bracket equals 0, the corresponding will be x equal plus and subtract minus 8. For the next one, the corresponding 0 for the first bracket here will be plus and subtract 2 over 3. The same way like you solve like this, it will equal, x will be equal this number, right? And for the second bracket, the x will be equal plus and subtract 4. The third one will be plus or subtract 4 over 3. And next will be plus and subtract 2. And this, the last one will be plus and subtract a over 3. And the last one will be plus and subtract 1. So this is the possible factors and possible corresponding 0, which is the x-intercept of this polynomial function. So basically that it is. But why do we bother to do all of this? Let me get into the next level. But why do we bother to do all of this? Because based on this, we will be able to establish the rational zero theorem, the formula for that. So if I establish the formula for the possible, right? Possible 0 will be equal. Now, if you look at on the factor of this, right? We might have a factor of 1, 2, 4, 8. So that comes from the last constant term, right? All of this to the right column here. So it could be all of this number here. And that's based on the factors of a constant term, right? That is a factor of on the constant term. What about 1 over 3, 2 over 3, 4 over 3? Where do you get this number? This number comes from 2 divided by 3 to get 2 over 3. 4 divided by 3 to get 4 over 3. 8 divided by 3 to get 8 over 3. So this is the factor of a constant term divided by a leading coefficient. these are the number come from, right? You can see that A divided by 3 is come from this number divided by this number. 2 divided by 3 is a factor of this divided by the leading coefficient. And therefore, based on this table data, we'll be able to establish the possible zero of the algebra expression or of a polynomial based on this formula. So all of these are possible factor of this. Could be whatever factor from the constant term plus with on the factor of the constant term divided by on the factor of the leading coefficient. So basically, if I have to list all of this factor, list all of factor, right? What do I list? I will list maybe it could be plus and subtract 1, 2, 4, 8, 1, 2, 4, 8. And actually in front of H is always a plus side, right? And minus side. And what else? Minus, plus and subtract 1 over 3, plus and subtract 2 over 3, plus and subtract 4 over 3, plus and subtract 8 over 3. So these are the possible root of the expression. Now, if I stop my video here, you will not be satisfied. I know for sure. But how do we going to apply this theorem to solve the factor of this expression? Now, the purpose of this lesson is given you a polynomial function. Doesn't matter quadratic function like this, or maybe a cubic function, or maybe x to the power 6, x to the power 5. With a long expression, or maybe a short expression, 3 terms like that. Without giving you the divisor, let's say they don't tell you divide this by x plus 1 or by x plus 2 in the long division and synthetic division we learned. Then how we be able to factor them without the division if we don't have any divisor? And based on all of this, right, we be able to guess what is the possible divisor, what is the possible value of x. Plug in the expression to make the expression become 0 so that we can do the synthetic division or long division because we're not given the divisor. So if the question just give you an algebraic expression or polynomial without tell you that divide by x plus 1 or divide by x minus 2, then you'll not be able to start from anywhere, right? So this theorem is helping you to figure out or guessing at least one possible factor, and then you can divide out from there. Okay, so let's figure out how do we're going to factor this expression. So I'm going to use this method, right? I'm going to say list of a factor. So the factor of 3, a constant term, what is the factor of 3? Is 1 plus subtract 1 and plus and subtract 3, right? What is the factor of 4 of the leading coefficient here? Will be plus and subtract 1 plus and subtract 2 plus and subtract 4. So now, if I want to figure out what is a possible 0 here, what is a possible 0 here? I will list them, right? The possible 0 is all of the factor of the constant term, which is plus subtract 1 or plus subtract 3. Also, could be the rational factor based on this formula. Factors of constant term divided by a leading coefficient. So I'm going to list them, follow the formula, right? Factor of constant term is 3. Maybe 3 over 2, right? That's one of them. Another one will be 4 over 2, right? 4 over 2, the same like 1/2. What else do I have? Or another one is plus subtract 3 over 4. So these are the possible root or possible zeros of this algebra or of this quadratic function. So now I know this. So let's say, fortunately, I pick up a number here. Let's say I pick up 1/2 and positive 1/2. So I try to figure out, does 1/2 plug in this expression, make this whole expression become 0, right? So my P of 1/2, so P stands for polynomial, right? Of this polynomial. This is the polynomial, right? P of x equal this. So follow this expression. I'm going to use 1/2 and plug in for x. We have 4 times 1/2 square minus 8 times 1/2 plus 3. Let's find out if they are equal 0. So that will be 4 times 1 over 4 minus 8 divided by 2 is minus 4 plus 3. Now 4 times 1 over 4 equal 1. 1 minus 4 plus 3 equal 0. So yes, my guess here is correct. If I just guess one number, now you can guess all of them or you can guess one of them. But usually we start by 1, we pick 1, right? If it doesn't work out and we start from plus 1, if not work out, we try minus 1. If not working out, we try 3 or minus 3, or maybe 1/2 or minus 1/2, something like this, to figure out at least one possible factor so we can start to divide out to get the factor done, right? So that's why that's the purpose for this lesson. So now we know that 1/2 is working. So we know that if x equal 1/2, then we'll be able to divide this, right? And I'm going to use the synthetic technique of synthetic we learned yesterday. Technique of synthetic division, right? We're going to factor this expression. So now we know as long as x equals 1/2. So the way I do synthetic, I'm copy the expression of the polynomial here without recording the x, right? So I will have 4 minus 8 and plus 3. Now I'm going to put in synthetic division and my factor should be 1/2. So I bring the first number down. 4 times 1/2 is 2. Adding them instead of subtract them, right? It opposite with long division. I got minus 6. Minus 6 times 1/2 is minus 3. 3 add minus 3 is 0. So yes, I have a remainder theorem is, the remainder here is 0, right? That's the remainder. So I know that this is my x squared. When I divide by 1 of x, so this will associate with 4x, right? Because x squared divided by x will be equal to x, right? And that will be minus 6. So this is one of my factor. And the first factor will come from our inspection here, right? X equal 1/2. So our first factor will be x minus 1/2. Now these two brackets, if you multiply them together, you will get the answer exactly the way it is, right? 4x squared minus 8x plus 3. And that's how we factor the polynomial function. This left side equals the right side. So by doing this, we'll be able to inspect what is the first possible thing, root, so we can divide and then factor out. So this is how we use a synthetic technique to factor. Let me recall you about the past. You already learned about math 10, which is you'll be able to factor this expression, no problem, right? We call a factor quadratic equation, quadratic function. And let me do that and compare with a new technique we learned in math 12, which is synthetic division like this, to be able to factor two brackets, right? So let me try if we use the old way, right? Okay, let's say a second way of factor, right? Second way. And the second way of factor is the way I factor quadratics. I will factor this become whether 4 times 1 or 2 times 2, right? There's two possible choices. And the last one will be 3 times 1. So then I put in the sideward, I say, my first choice, maybe I pick this one, 2 times 2. And my second choice from here, 3 times 1. I'm going to do cross multiply. 2 times 1 is 2. 2 times 3 is 6. As long as I add these two numbers, I get back to the midterm here, then I'm okay. So I'm going to assign the correct side for this will be negative. Negative 6 minus negative 2. It will be equal minus 8. So then I know that these numbers are working well because I test this and I have minus 6 at minus 2 equal minus 8. So I'm going to circle the first one and I'm going to circle the second circle. These are the two brackets of my factor. So factor means you put them into bracket, right? In such a way, you tie them, they get back to original. So my first bracket, these two numbers go in here. So that will be 2x. The sign, I will collect it from here, right? Because that's the sign I should have. Negative sign, minus 3, right? Negative. And the next number will be 2x. And the sign I pick up from here too. So minus 1. Now I'm sure that I check the last term, minus 3 times minus 1 equal positive 3. So I'm safe. I know that these factors are correct. So this is the second way of factor. In math 10, you have learned how to factor the quadratic function. Now, maybe another teacher will show you another way, but that's the way I factor, right? I got these two brackets and they must correct. So now the question is, we have a two bracket look like this if we use the synthetic. Now we also have two bracket look like this if we use the old way of how we factor before. So which are the correct factor? Now the answer, of course, they both correct, right? We can factor in this way or we can factor in this way as well. But keep in mind that in math 10, if you do this factor, you can't factor quadratic function. You only can factor the degree of 2, x to the power 2. But what about if you use synthetic like this? You can factor like yesterday I showed you x to the power 5, x to the power 6, x to the power 7, right? So that's the difference. That's why the math is progressed into a higher level, enabling you to factor all type of algebraic expression, not just the degree 2, like we learned in math 10. And that's the purpose of why we bother to learn synthetic division or long division, to be able to factor the algebraic expression with the higher degree, with the higher level, or long expression, rather than just short. Now, because my purpose is explaining to you the factor theorem, the rational zero theorem, and therefore I choose the symbol expression to show you, right? So now how do we check that our answer is correct? Remember, we say that the corresponding zero is the root of the function. So if we zone this factor, right, we zone them, and we end up with whether we factor like this or we factor down here, and we get the same answer of the arc-intercept or the roots of the function, and they look the same, then we know that they both correct, right? So let's do that. So to do that, I have to borrow a bar from here. So I'm going to erase some of this here so I can show you. And I'm going to leave the formula down here because this is the importance formula we learned, right, from our theorem today. So let's say if I zone this one, right? I have x minus 1/2 equals 0. I set equals 0, move it over. I have x equals 1/2. For the second bracket, I have 4x minus 6 equals 0. Move it over. I have 4x equals 6. So x equals 6 divided by 4 or equal 3/2. So this is the answer if I use synthetic division, right? That's the zero I have, right? That's the zeros or the arc-intercept. Now, using the quadratic function, keep in mind that you only can do this because you have a degree of 2, right? So let's do that. 2x minus 3 equals 0. X will be equal, move it over 3/2. So look like this one. The next one, 2x minus 1. So 2x minus 1 equals 0. X equal, move it over 1/2, right? So yes, either way, I come up with the same answer of the 0. Either I factor like this using synthetic, or I factor like this using quadratic factor, I get the same answer. Same answer for the 0, right? Or the x-intercept or the roots of the polynomial function, whatever you want to call it. So this is the lesson I would like to show you about the rational zero theorem. So just remember that given you a polynomial regression, without the divisor, you don't know where you start. You don't know what was number x, so I can put into divide down using long division or synthetic division. Then this is the way you guess. You can guess by this formula. You can choose the factor of the constant number here. If, let's say here you have two choices, right? You put 3 in here and it doesn't work out. And you put 1 in this to see if you get 0 and doesn't work out. Then you have a third choice, which is you use 3 divided by 4, or maybe 3 divided by 2, whatever factor. The constant term here, the factor of constant, divide by a leading coefficient, which is this one. A leading coefficient, actually, I should say, not just the leading of coefficient, but I should say that factor of a leading coefficient. So it means you can have 3 divided by 4 or 3 divided by 2 or so these are the possibility, right? You can have 1 or 3 or 3 divided by 2 because 2 is the factor of 4, right? Or 1, right? 1 is the factor of 3 divided by 2. So 1/2. So that is the possibility. You can pick it up to guess so that you can start for the synthetic division. So that is the purpose of the lesson today. I'm going to end the video here, and I will see you in the next video. In the next video, I will talk about the solving polynomial function by factoring like this, or by solving the polynomial function. Now, the only way we can solve the polynomial function by using the factoring like that, but there will be variety of type of questions, right? And you will see there when I make another video to help you to solve the polynomial function. And also, there's a lot of application about this topic, this unit. We can word problems in polynomial solving problems related to the real life. So I will show you all of that. Thanks for watching, and bye for now.